So hello everyone. Glad to have you here all, and let's dive to our first topic. So as Rimbidas mentioned, I will be speaking um, uh, about testing in Java, and uh, as testing begins, it always good idea to have base ground and to discuss some most fundamental topics. So I prepared for you the presentation that will be comprised from two parts. So the first part will be where I'll give you the presentation, when we'll discuss the topics and the major ingredients in testing. And the second part will be more like a practical part, when we'll discuss topics and items practically. We'll have some code examples, and we can see how it works in real life. So let's begin. I just want to ask you, do you see my screen?
Yes, we can see Arunas.
Okay, thank you. So let's begin. So okay, so agenda of my today's topic will be first I'll introduce myself, then we will discuss why testing is needed in a broad sense, what are the best practices, and what are the types, how we can name our methods, how we can name our variables, and what are the general best practices of doing that. Then later I'll touch the test pyramid. It's kind of similar pyramid, like a Maslow pyramid in psychology, but we have the same pyramid in the test context, in a testing context. So we'll discuss that. And next, I'll speak about test doubles, how we can create those doubles, how we use them, what are the types of those test doubles. Also touch regarding what tools and libraries we'll be using. And as I said, the second part will be a coding session. So for the first part, there will be questions and answer sessions in the end of the presentation. And later, when we'll do a practical part, so you can ask questions as we go. So let's begin. So shortly about me. So first of all, we have a baby born, and he came to my family not so long ago. So we're very happy to have him. And you see the picture. His name is Simon. And yeah, I'm coding Java for more than 10 years, and I'm working in Zenitech for around 1 year. And I worked on legacy projects, worked on greenfield projects, and so when tests are in place, what are the benefits and what are the pitfalls when we don't have the tests in legacy projects, and how to start writing those tests for the greenfield projects, what tools we can use, and what are the best practices. And also I want to tell you that sharing your ideas and knowledge is very good for others and for yourself, because the best way to learn is to present or to teach others. So I encourage you to also share your ideas, do presentations in another channels, and to be engaged in our society, like Automate IT, and maybe in your society. But just be active and proactive, and you will see the benefits. So sometimes people say that why do we need those tests? And tests slow down our speed, how fast we can deliver new features, how fast we can fix bugs, and so on. But this statement is not correct, and the time taken to write tests, it slows us only in the beginning. So for example, if we have greenfield project, that means that we don't have any legacy code, and we are starting to write our code from the blank page. So of course, when you don't write tests, you can move faster in the beginning. But after some time, when you have some code base evolved, you have the situation when it's kind of difficult and sometimes maybe not even possible to do something without being confident that you will not break something else or not break some code that you've written some time ago. And tests, if you have tests in place, they are like a safety net, and they help you to be confident that when you introduce the new feature later or you fix some bug, you know for sure that you are not breaking any functionality that was done previously. So after some time, when the project is running, you see the curves a regression, and you always deliver in a steady pace the new functionality when you have tests. And when you don't have them, it slows you down. And after some time, the pace with tests might be better, and you'll have more code and can deliver faster. Also, we should not talk about ourselves. We should think about our colleagues, the developers or QAs that joined the team, and maybe they were not from the beginning on the project, and it will be way faster for them, and they will feel more confident when those tests are in place, and when they try to understand the system, they can actually check the tests, how the tests run, and they're really confident that when they do some functionality, something is not broken. So yeah, as I said, tests sometimes can be like evolving system documentation, and it's really good to see tests like that because you can understand the system from the tests, and you can see how the system should behave only reading the tests. And what is very good about that is that if you have documentation as tests and not like a separate document, you always have to update the tests when you update your code base. Because if you don't update your tests, you just fail. And with separate documentation, I've seen a lot of times that somebody forgets to update the documentation, and after some time, the documentation starts to live a separate life, and it doesn't actually show and explain how the system is working. And these days, as you might already know, companies are moving more to automating everything and automating the tests. So quality assurance teams or team members that are responsible for this role, they also start to program. They take some responsibilities that developers have. They write the code because tests are actually the code. They check the infrastructure, they configure the project, and so on. And we as developers, we also write tests, and we also ensure from our code base that functionality is working as we expect. And I think it's business crucial to have software tested before we go to production. And I think took this sentence from Martin Fowler blog, and I think this is really important to talk about this, because some businesses they cannot have errors when we deploy new features, and it's very crucial to have this really good user experience. And with tests, you can be sure that almost sure, you can never be sure, but you can be more confident that everything will go fine. So now the next slide, talking about how we'll test our systems, and we have two general ideas how we're testing the system. So the first one is the system is like a black box for us, and we don't know how components are connected between and how that functionality is created. We only know that when we give some input, we want to get some output, and we don't know how it came to give us that output. And the second type of testing is white box. As a contrary to the black box, we have white box testing when we know actually the components that comprise the system, and we can then test those components isolated. We can check, of course, like in the black box, all the system as if the system behaves as we expect as a whole, like a functional testing, and also we can check if some component behaves as we expect. So we take that one component, and we create some test doubles. I'll speak about those later. That enables us to test only that small component, and to know that this component works. Then we can check another component, and in this sense, we check the whole components that comprise the system. So when we're testing, it's very good to call your system to have some defined variable names, how you call your system, and of course you can call them in your project as you want. Just be consistent. But as a suggestion, you can call your system on the test as SUT. It's an acronym for System Under Test. And of course, when you write the test, you create test oracles. And test oracle is a mechanism how you determine if test passed or failed. So you have some conditions set, and after the test, you check them. So this is your test oracle. Yeah, and regression, as I was telling previously, regression is when you develop new functionality, or you try to fix some bug you broken already existing functionality that was created some time ago. So this is the regression. And the next slide, let's speak about some more general ideas and principles regarding tests. So there is this acronym FIRST. You can see the ingredients of this acronym, and of course, the first one, your tests, they should be fast. And by fast, I mean that developers should be able to run them as many times as they need, and after some changes is introduced, it should be not a question to run the tests. And if those tests run really long time, it degrades the speed how you produce new functionality, and sometimes maybe developers or QAs or other engineers just will skip those, and it's really bad. The second one, your tests, they should be isolated and independent from each other and from any infrastructure or configuration or some variables that change. So it means that doesn't matter in what order you run your tests or what data you provide to a test. The test should give you the same result every time, and it's the point three that they have to be repeatable, and by being isolated you can be sure that nothing will change the data or some another variable from previous tests. The fourth point is self-validating. It means that tests should validate themselves. It's the one that I told you in the previous slide is test oracle. It's how you say that your test passed or not, and they should be also timely and thorough. There are some principles that you use at your code, and I encourage you to also use that and them in your tests, because tests, they actually are, in the end of the day, the code. So there is principle dry, when you don't repeat yourself and you don't copy paste the code, but extract the functionality that is reused. You give descriptive and meaningful phrases and names for another developer or QA just to know and see from the names and from your test structure what is going on. And of course, KISS principle, when you just keep it simple, stupid. So moving on to test pyramid. So this pyramid shows us the types of tests, and in the bottom of the pyramid you see unit tests, and they take the biggest part of that pyramid, and it should also reflect in your system, and unit tests should take the biggest part of your testing suite. First of all, because they're fast. Second of all, because you can check them very thoroughly, and I'll show you practically and in the next slides how. And of course, going up, we have component tests. When we have those unit tests working together as a component, then we have integration tests between those components, system tests when we have all our system working and loaded. For example, web container running and server running, and we're actually calling the endpoints as an end user. And in the top, we have manual tests, because sometimes it's not feasible and it's not recommended to automate everything, because some work can be tested manually very fast, and it doesn't have to be automated. So it's for you to decide. And of course, having unit tests, we have to have all the tests in this pyramid to know and to be sure that our system is thoroughly tested and it behaves as we expected. So today's my topic is more about unit tests, and that part that takes the biggest part of your test suite. And I talked a lot with people and testers regarding unit tests and everything. Everyone seems to speak about mocks. Yeah, we do mocks. We use them as test doubles, and we say what we want to get, and mock does it. But actually, we have five types of test doubles. So I'll talk now about them, and I'll show you in the code how they differ. So first of all, there is a dummy test double, and it's really only the, for example, some object created or some reference that is passed as an argument or just is passed as a dependency, but is actually never used. Um, Second is fake test double. When we have the alternative implementation of our real dependency. And as example, we can think about fake for database, like interface implemented that our data store implements, but all the data is saved in the memory, for example. So fake actually, when we call the interface to save the data, it actually has to save the data. And querying the data, we should get what we already saved. So it's not real implementation, but it's faking the functionality of a real component. For example, if real component is really heavy or we cannot use it isolated in our code base. For example, if I run my test from my laptop and my colleague runs from his laptop, and we're using some database that is created in our infrastructure, then we're not isolated from each other, and we might change some data that we depend. For example, my colleague can change the data that I am reading, and my test might run or might be broken, and it depends when I run it, before the colleague changed the data or after. The third one, test double, is stub. It's it's like a fake. It implements the interface, but it actually only returns the data. So, for example, if we have our database implementation and we have method to get some data, some entities from the database, so our stub will always return the same result that we created and what we specified to be returned. And now, on the contrary, we have mock and spy test doubles. And they are kind of different. They, first of all, are different from the first three, and they're a little bit different between each other. So, first of all, mock, it acts like a stub. You define when I call this dependency, my test double, I want this mock to return me some results, and it does it. No matter how many times I call it, it returns me the same results. But in the same time, it records the interactions. So after the test run, I can check how many times I call that method, and the mock provides me this information. And the spy, it's also records the actions. It's almost like mock. It records the actions, and we can mock some methods. But under the hood, the spy takes the real object implementation. So, for example, we have some big class with 20 public methods, and we want to have actual real implementation in place in our tests, but we only want to mock some methods, for example, 2 or 3 methods. So we can do that with spy. So we'll see all of this in our second part of the presentation. So when we are controlling our dependencies, we create them like a stub, fake, or mock, spy. We actually control them, and we define what we want them to return us when we call them, and we can check how many times we call them. But if we are not controlling the dependencies, as was an example with database that is reused, we can have flaky tests, and it's really bad because when your tests sometimes runs, sometimes breaks, you don't know if it's working or not, and usually you cannot say that if test doesn't pass, your software is not working. It just says that something was changed. So controlling the dependencies, you don't have that risk of changing dependencies, and you isolate your tests as you have a need. Yeah, so going on. So next, what tools we'll be using? In Java, we have Mockito, of course. The testing framework is the standard in the Java testing framework environment. Sorry, and there are other tools that enable us to have these flexible expressions and fluid APIs, how we can check the data, and all this will be also in the second part. We'll see how this is working. And I just wanted to mention that we have some another testing techniques or framework tools, you might call it as you wish, like mutational testing is when you actually test your tests. And we're actually in Zenitech, we're doing that. And it actually enables us as developers and QAs to see not only that our test coverage is good, but if our tests are really good. And property testing is the type of testing when we not only define what inputs should be given to our test, but we define how to generate those inputs and some property that has to be as a predicate met after the test runs. And it generates lots of inputs to our tests, and we can grab those special edge cases with property testing. For example, it might be encryption decryption, when encrypted text should be always the same as decrypted, and you can provide text in any language, big text, short text, and so on, and you can really get the feeling where the bug is lurking. So yeah, thank you very much. This was the first part. So now, if you have any questions, please ask.
Arunas, we would like to leave questions for after the live coding part.
Okay, thank you, Rimlis. Thank you. Yeah, so let's go to coding part. Yeah, so for coding part, we'll have a real life example. We'll have the domain model that I will introduce to you shortly, and then we'll write those tests on that domain model. So it will enable us to better understand real examples and how tests are used. So we have object, we have class artist, and we're talking about musician. So that musician has artist name, it has a genre, it's simple and known with types of music, and our artist has one genre at this example. And every artist has a set of albums that were released, and every album has album name, has a release date, and a list of songs, because song order is important. I'm using list here, and for artist albums I'm using set because it doesn't matter the order, as we have release date in the album provided. And as a utility method, I created the artist factory. This factory is used in our tests just to be able to quickly create artists on the fly that will be used in our tests. So what we do here, we select randomly how many albums we would like to create, and it will be created from 1 to 4 excluded. It means to 3 albums, to sorry, to 3 to 3 albums, and every album will have from 1 to 10 songs, because songs are also exclusive. And all those albums for the tests, let's say they were released in September, some day in September. Okay, so this is our core model, and now let's go to our tests. So in the test we have artist service, and artist service it has 2 public methods. We can save the artist, you can see it here, and we can then find the artist with the name, by the artist name. So I'm logging everything, and I'm using the dependency of artist repository. And artist repository, it also has 2 methods, save and find. You can see it here that save will call artist repository save, and find will call artist repository find. And we have actual implementation that does nothing. But throws runtime exception. So anytime we call save or find, we'll get the exception. And let's begin. So the first one, test double, that I would like to speak about and show you how it's working. It's fake. As you remember, fake is a fake implementation of the interface that actually provides the functionality that our dependency has, but not uses the dependency. And for repository, what I did, I created, as you see here, we have external artist repository, and I created as a fake local artist repository. So let me show you what we have in the local artist repository. First of all, we have those 2 methods, as I said, implemented, and we're not actually saving the data to database or calling some API to save the data. We have data saved in our map. That is private member of this local repository. So every time we'll call save artist, we will put that artist to our map, and calling find, we will return from the map the artist name. And for example, if we now pass this fake as our dependency, we can have isolated unit test of our artist service. So as you see now, I am creating in a fake test, I am creating this fake artist local repository that will save data to map, and I'm passing this dependency test double to artist service. And then the simple test only creates with factory, as I showed you previously, creates artist, saves it, and when we check that the artist that we get from the artist service by the name is the same as we have created and have passed to save. So if we run this test, we'll see that it's working, and it doesn't actually throw us runtime exception that will happen if we'll be depending on that external artist repository. Also, I would like to mention in this test that it comes from BDD practice, behavioral driven development. When we define what is given, for example, what data is given, then when we do something, then we assume that something should happen or we should get something. So this is very good naming strategy, and we're using a lot this in our projects. You can read it and you can get the feeling of what is going on. Like given the fake repository that we created, when saving and finding artist, then return saved. Okay. Yeah, and now let's see another examples when we'll be using not fake but mock test doubles. So for that reason, we're using Mojito library, as I mentioned previously, and Mojito library has a really good and very easy to use tools how we can mock our test doubles. So in this example, you can see that artist repository, we define artist repository as a private member and mark it with annotation mock. It says to Mojito framework to create for us the mock. And with inject mocks, we say that please inject to artist repository the mocks, the test doubles that it needs, and it needs artist repository. So it understands that we have to inject the created mock. And before each, we were telling the Mojito to actually init those mocks. So let's see what does this test do. And what we have, yeah, we can read from the name. So given dummy repository, when saving and finding artist, then return null. Yeah, so we have mock created, and actually, if we don't define any functionality or return, the mocked return, it only for mock functionality does nothing. For example, with save, our repository will not save it anywhere and will not throw the exception. And when we do find, it also will not return anything but null. So you can see that the test passes, and we have assertion that assert when we call the artist service that it has to be null. We're using here JUnit 5 Jupyter assertions, and yeah, also I would like to mention that this project will be available, as Rimvidas mentioned, in some repositories, so you can just take it and try to work it with on your examples. Try to see if your assumptions are correct or not, or create some new tests. In second test, we are actually now mocking the functionality. So, for example, we would like to say that when we are calling the artist repository with any object, with any string, please return to us artist. And we don't need this artist service save artist, because mock now is configured for us to return actually the artist. It doesn't matter how many times we'll be calling it. Let's run it. It's green. If we'll do uncomment the save, nothing should be changed. The test is still green, so it's a redundant operation, and just written here as a marker to mention that. And as I said, mocks and spies, they have additional functionality when we can check how many times the method was called. And for example, in the third tests, you can see that we're mocking, once again, mocking artist repository find method. We say that when we'll be calling artist repository find with any string, then please return the artist. And artist is statically created artist. Uh, uh, then, when we mocked this functionality, we actually are calling the save method of artist service. And here you can see later that after we call save, we first of all are expecting to get the artist from artist repository. And we'll get it because we mocked, and it will always return the artist, so it will be passed. And we also assume how many times, we check how many times our mock was called. So you see that artist repository has to be called one time in this line, and artist repository has to be called one time we find in this line. So if I run this test, it will be green. And later, let's for example have two lines with save, and the test now should not pass. And you see, test is not passing, and we see that we wanted one time and we got two times. So mocks are kind of different from fakes, and they give us additional functionality that we can use. And as I said, I'll show you also the SPY method. So in the SPY method, we also inject it and use, as previously with mock annotation, but we annotate our artist repository as SPY. And as you see, we are creating actual object. And that actual external artist repository, as you might remember, it has two methods that throws exception. So if I not mock any methods in this artist repository, we should expect the exception to be thrown. And the first method that you see, it actually asserts that the runtime exception should be thrown from artist service. If I run it, it will be green because actually the exception is thrown. This one does the same, but we actually are calling the find method. If you wish, we can do this this way, just to see the stack trace that exception is thrown. Let's once again run it. Yeah, we have exception, runtime exception in artist repository, what we already discussed. And let's go next to SPY functionality. And first of all, we would like to, the same way as we did with mock, with SPY, mock the functionality, mock the find method, but with SPY, it's a little bit different than Mojito. So I just want to show you how it's done. We're not writing as we did with mock. With mock, we wrote when some method is called, then return. But with SPY, we do return something when our test double and its method. And if we'll do the same what we've done with mock, it will simply not work. So this is the thing to have in mind. So now you see that test is green, but for example, if I enable the second line, it should not work and it should not mock the functionality. And it actually, why it's not working? Because actually it mocks the result that is returned, but before that it calls the actual implementation, and actual implementation throws the exception. So before we get the mocked result, we get the exception. So this is the thing to have in mind. And of course, the same as we discussed with mocks, we can check how many times the method was called. So when we this is the functionality to mock the save and find of our test double our repository that we're having mocked, and we're actually calling save, and we're actually calling the find. And after that, we check that one time has to be called save and one time has to be called find. Let's run it. Let's run it, and the test is green. And some tools that I mentioned in my presentation was some tools that we also use, and they have some additional functions, some additional logic and functionality that you can use in your projects, and it's really useful. And let me show you the example. So in this example, I created two methods. One method is using simple assertions that come from JUnit 5. And in another test method, we have assertions that come from Crest. You see this. And they actually do the same. They actually, first of all, they actually create the data. And afterwards, we do some test assertions, our test oracles, as you might remember. So, for example, if we get from saved artist albums and we want to check that return set is not empty, we write it in this manner. We write assert false. Okay, you have to remember something will be false, and false will have to be that albums is empty. So what does it mean? Albums has to be not empty. Okay, and the same way how we can write that in Crest, it's very fluent and very easy to read, and it's written in this sense. It states assert that. Okay, assert that something saved artists get albums is not empty. Once again, assert that something is not empty. It's very fluent and very easy to read, and also I encourage you to use it and to see the benefits. And we also can check, for example, with Crest, if it that set or our list in this example has an item, or every item starts with some string. And for example, with a simple JUnit functionality, we'll need to iterate iterate all songs and to apply some assertion on every item. And the last two that I would like to show you. One more is assert J functionality. It should not be mistaken with assertions in JUnit. It's a separate library that is very, very also fluid, and it has lots of functionality. And when you write your tests, what you actually do, you write it like a prose. You write some assumption, and then after that assumption, you can write some more assumption, and so on. And for example, if we call our service with find, we get a saved artist, and we write it in this manner. We write it assert that artist is not null. If it's not fail, if it doesn't fail, then go to this line, assert is equal to something, and then matches to something. It's very fluent, and it saves mental power to understand what is happening in the test, and it has also lots of functionality. For example, we can go inside of some property of of our return result and check that that property contains something and doesn't contain something, and so on and so forth. It has functionality to check size and to check, for example, size range. And the last one is capture. Is the functionality? I think it comes from Mojita. Yeah, if I remember, yeah, it comes from Mojita. And what it does, we actually can capture what parameter, what argument was passed to our test double. So, for example, if we'll have some argument passed to delegate create artist method, and we mock that method, we can say that we would like to capture with artist name capture what the actual parameter was passed. And after that, we can check in our tests what that parameter was actual passed our test. So, for example, if I write something else here, and this is the actual call to our SPY that has our actual implementation inside, you can see that it reflects the same as we actually called. Yeah, so there are a lot of things more to discuss, and I encourage you to play with this project. You can in a very short time create your own tests. Everything is set up. Everything is done with Maven and with Java 14. And yeah, that's it from my side. And now, if you have any questions, we have, I think, more than 10 minutes to answer those or to discuss. So thank you very much, and waiting for the questions.
Thank you, Arunas, for a great presentation. We do have a few questions indeed. So first one is from Thomas. So the question is test coverage a good metric to measure test quality?
This is a very good question. Actually, it depends. And why I say so? Of course, if our test coverage is reaches some percent, it means that we have tests in place, and this is very good sign. But actually, if we have complicated logic, and for example, we have if statement or a predicate statement in one line that has three conditions that has to be met. So if you check in your test one condition, the test code coverage will show you that that line is actually covered, but you're checking only one condition, and your tests are not thoroughly testing your functionality. So the test coverage is a good sign, but it doesn't give us the confidence that that our test actually test what we expect them to test. And for that reason, as I mentioned, we have mutational tests that I encourage you to get to know what it is, because it actually checks your tests. We test our tests, and how we do that, it actually mutates the code and checks after the code mutation if your tests passes or they fails. And you might, as you might guess, if you change your code base, some of your tests should fail. And if it fails, then everything is fine. If it doesn't fail, but you mutated your code base, then your tests are not testing what you expect. And example with three if conditions. For example, we're testing only the first condition and two two are left behind. So our mutational tests would, for example, mutate the sign or variable in that condition, and your test will not fail. So yeah, test coverage is good, but it's not the only tool that should be used.
Thank you. We have another question. Question from Vita. Is it really correct to have few asserts in one test?
Very good question. It depends. If those asserts in your test they come together and they have they have to be like invariance of the result that you get from your service or the system that you test. You of course can and should check all those properties and all your test oracles when they are logically connected. But if you have a big test and lots of assertions, and those assertions could be split to separate tests, it's way better to have separate tests. First of all, because you will be isolating the test oracles and test assertions. And when you change something and your test fails, you know for sure what is happening wrong. When you divide those assertions to separate tests. And when you have those tests all in one place, you'll have the first assertion failed, and the other assertions will not be checked, and you will not see the whole picture, and you'll not get from the first run the idea of everything that was broken.
Thank you, Arunas. We have the third question for you. Question from Neringa. Do we need integration tests if we fully covered all functionality with unit tests?
Yes, we do. Yes, we do. And unit tests enable us to run tests very fast, to isolate them with our test doubles, as you saw in my presentation. But integration tests has to be in place, and it is better to have them in environment setup the same that you will have in production. And your integration tests will show if actual thing is working, if actual functionality is working. Because if we checked only the separate parts with unit tests, we cannot be sure that they are actually delivering the functionality that end user is expecting, and if everything works fine when those components and our parts are connected to final product. So yes, integration tests are really needed.